So welcome everyone. I'm so glad to have you here today. We are going to go explore some careers in engineering and kind of explore what studying different programs in engineering can lead to in terms of careers. So thank you so much for joining me. If you haven't been in this platform before, you can toggle between looking at the presentation if you'd like, or watching me speak if that's more engaging to you. It's totally up to you, but you can click on the little box that has my picture in it to make that bigger if that is your preference. So I just like to let everyone know that because they have different preferences for watching the presentation. I will be showing a few things in this presentation, such as some video. So there will be a couple of short clips that we're sharing that will be on video. This is my first time using video in this particular platform, so I will get you when we get to that point to give me, just let me know in the chat that it's working for you in case it's not. Perfect. So my name is Erin. I am the student recruitment officer for UBC Engineering. So my job is to help students who are interested in coming into engineering, and doing these presentations is one of those ways that I do that. So if you are considering engineering, we have lots of other presentations from earlier this year on our events website. So feel free to check that out for more information, like more details about admission requirements and things like that. We also have some comparisons of kind of the difference between science and engineering and lots of different presentations on there already. So we're not going to go into any of the admissions components because those already exist. We have those presentations already, but this one is a brand new one all about exploring careers in engineering. So just for a quick recap about UBC Engineering, we have two campuses. So at the Okanagan campus in Kelowna, we have 4 programs offered there. And then at the Vancouver campus in Vancouver, we have 14 programs offered there. So 4 of the same programs from the Okanagan campus and 10 additional programs are offered. So just a refresh of kind of what some of those programs are. Now, regardless of which campus you're on and which program you're in, there's a lot of similarities between them. And one of the things that we really strive for at UBC is that students will get hands-on design experience all the way from the first year in doing your projects in your AppSci 100 and AppSci 101 course, continuing into project-based team learning throughout your degree and finishing with your capstone design project in your senior year where you get to work with industry professionals. Now, we also have a lot of work and international experience that you can get as part of your degree. So while you're already in school, you can work in the co-op program, and that allows you to get paid work experience in engineering fields as part of your degree. Students can get up to 20 months of paid work experience as part of that program. So that's one really great opportunity to get that work experience in engineering before you even graduate. And we also have a lot of international opportunities. So if you wanted to go abroad and study engineering somewhere else, you can do that. You can also work internationally. So there's a lot of kind of exciting opportunities where you can get some of that additional engineering experience outside of the classroom. Now, I do want to mention our Engineering Stories channel on YouTube. So I have current students that work for me that basically their job is to film what student life is like and to talk about engineering and engineering degrees and what that's all kind of about. So Crystal recently published this one about what you can do with an engineering degree. And there are so many opportunities. So she goes into some details about kind of some of the more untraditional paths. So if you are interested in doing kind of research or business or finance, medicine, law, entrepreneurship, those are all career opportunities that you have in engineering that are not necessarily the traditional path. Today, we're going to focus a little bit more on some of those traditional paths regarding each program. But definitely check out Crystal's video if you want to learn a little bit more about some of those less traditional paths. And I see that there's a first question in the chat. So does that mean that you need to take an extra year if you pick co-op? Yes. So if you apply into co-op in year 2, that's the earliest that you can apply into the co-op program. You will add a year to your degree. It's only adding a year to your degree, and you're going to get 20 months of work experience as part of that. So you are going to be working in summer terms or some winter terms as well throughout your year, or throughout the next kind of 3 years of school. So hopefully that makes sense. Perfect. So regardless of which program that you choose to go into, there are skills that basically every engineering student is going to pick up, and those are skills that will apply to what you do for work. So that's what we're going to jump into for now. So any engineer is going to basically do what all engineers do and apply science to solve problems. That's essentially the basis of engineering, and so that is what one of the main skills that you're obviously going to take away from engineering. You're also going to get a lot of really specialized understanding of different tools and equipment and different technology, especially depending on which different program you go into. You'll learn more about in-depth computational analysis and statistical techniques to understand and interpret complex data. You'll also have a lot of experience doing different research, different economic analysis, feasibility tests. Those are all things that engineers typically do no matter what program that they're in. A lot of our courses, as I already mentioned, have team-based project learning. So you're going to learn leadership skills as well, so that when you, as an engineer, you have those leadership abilities and you can actually lead these projects as well. Every engineer requires great communication. Even though it might not be the first thing that you think of, engineers need really great oral and written communication, and you actually have several communication courses that you take as part of your degree. You're also going to be constantly problem solving. Again, engineering, kind of the main foundation of engineering is problem solving and solving those problems to make our world a better place. So engineering has a huge impact on the world around us. It impacts our society, our environment, our medicine, our technology, all of those things. And so that's one thing that you will really work on as part of your degree. No matter which program you're in, you'll learn about sustainability, you'll learn about all the different things in the world that engineering will impact. So those are kind of the basics. Now what we're going to jump into more is what I always get asked about, is more about each individual program. And so we're actually going to spend a little bit of time today going through all of the individual programs that we have, some of the skills that you'll learn, some of the jobs available, some of the companies that our current co-op students might be working for. So these are very limited in terms of the depth that I'm going into, because we would be here for hours if I went into depth into every single program. But I did want to go through kind of all of our programs quickly so that you get a sense of what some of these students have gone on to do. And then I have a couple video clips of some of our recent alumni that are working in the field. And so they'll share kind of their experience of what they're doing in their current job right now. So biomedical engineering basically takes engineering principles and design and applies it to medicine and biology for healthcare purposes. So it's not the same as being a doctor, but it is working to make doctors' lives better, potentially, or patients' lives better, because you are improving various items in the healthcare system. So things like better diagnostic machines, things like, if you have X-rays or CAT scans or things like that. So in biomedical engineering, there are 4 main pillars or streams of the program. And they are biomechanics and biomaterials, bioinformatics, cellular engineering, and biomedical systems and signals. So within that, there are a lot of different skills that you could learn as part of the biomedical engineering program. No matter what stream you're in, you'll definitely be collaborating in multidisciplinary teams to design medical diagnostic equipment or analyze measurements captured from imaging and electronic sensing technologies like wearable sensors or X-rays or MRIs, like I kind of mentioned. You'll be applying physiology and medicine to develop cell-based therapeutics, like gene therapy or tissue engineered organs. So there's so many things within biomedical engineering that you can go on to do. You can see a list of the career titles and some of the companies that our students are currently working for or typically will work for. And on to the next one is chemical and biological engineering. So these types of engineers develop sustainable green manufacturing technologies for the production of superior medicines, clean water, cleaner fuels and materials, and cutting-edge medical technologies. So quite a wide breadth of option within this program as well. A lot of what you'll be doing is designing and testing process equipment. So whether that's like valves or vessels or pumps or heat exchangers or pipes, all sorts of different things. A lot of what you'll be using is using computer software as well to design these processes, and can really touch on anything that is related to environmental engineering, related to biomedical engineering, but really looking at those kind of natural resources and utilizing them. So again, you can see a list of some examples of career titles in companies. The next one is chemical engineering, so very, very similar to chemical and biological engineering. Chemical engineers are really very universal. They creatively and innovatively solve global energy, water, and environmental issues while transforming raw materials into products that society depends on. So very similar to the last one I mentioned. But you will see that some of the career titles are a little bit different. So looking at things more along the lines of strictly chemical processing is what a lot of these chemical engineers will do. So I have an example of a chemical engineer. So if I am going to start a video, if you can give me a smiley face if it is working for you in the chat, that'd be great. If you can type in if it's not working for you, then please let me know that as well, just so I can make sure that you can all hear the video okay. But this clip I'm going to show you is from our new series, Behind the Career from Engineering Stories. It's a pretty short clip. And Ashna is a junior process engineer with a green engineering company. And this company is actually the same one that she worked for during her capstone project. So I mentioned those capstone projects that you get that work experience working with industry professionals as one of your courses. And so she actually enjoyed working with them so much that now she is actually working for them as an employee.
Moving on to the second question, what is a typical day at work for you as a process engineer?
Okay, so I think, and this is probably true for a lot of design engineers, is that...
Oops, sorry, that was my fault. Let me try that again.
Moving on to the second question, what is a typical day at work for you as a process engineer?
Okay, so I think, and this is probably true for a lot of design engineers, is that your typical day will change a lot depending on where you are in a project cycle. So if you're in the design phase, a lot of your day might be, specifying equipment or making process flow diagrams, just kind of getting the blueprint of a system ready. And then as you move through a project cycle into commissioning or aftercare, so a plant is already done and now you're having issues with the plant, your day will look very different. In my case, we have lots of projects going on and they're all at different stages of the cycle. So my day can be very mixed. And it always starts, especially in the age of COVID, with a morning meeting call just to make sure that everybody's on the same page, especially when we can't see each other physically. So I'll start my day, I'll have some emails, take care of lots of little questions that I might have from other departments. And then we'll have our morning meeting, and this is where you really set the stage. It's okay, these are the urgent issues of the day. This is a problem that's happening, and who can solve it? So then we move on to the next stage, which is I will work towards solving that problem. You'll have lots of other meetings on the subject. Oftentimes we have a couple of meetings a day about suppliers designing new projects. And then, as far as design work goes, as a process engineer, I really like I like, and it is my job to make process and instrumentation diagrams. This is something that we don't really see very much of until I think 3rd or 4th year of chemical engineering, but they're basically like two-dimensional diagrams of the system. So you as a mechanical engineer will actually take this diagram and you will turn it into a SolidWorks model or like equipment. And it's like very interesting to see the difference between the two, because a process and instrumentation diagram, they're all symbols and they're like built for a user to understand how like media or gas flows through a system. And like this is the one base document from which electrical and mechanical engineers go forth to do the rest of the job, which is building it into actuality. And that diagram is so different from what comes out as the final mechanical product, because in the diagram you might have one line that goes from here to here, but the physical pipe might go like up and down and around, which is really cool to me. And so a lot of my day will be building those diagrams and then working with mechanical and electrical engineers to see, does it include all the components that we need? Should I move things around so it makes more sense in the physical model? And that's what a lot of my day is. Yeah.
That is awesome. So when you're in undergrad.
Perfect. So hopefully you enjoyed that little clip. That's one of our longest video clips. So there is still lots more that we'll be going through. But that's just one example. So Ashna, as I mentioned, is working in chemical engineering, and that is a way to really see that you can see that she's working not only with other chemical engineers, but she's working, she mentioned electrical engineers, mechanical engineers, and so engineers do really work together in lots of different areas. Even if you're in one field of or one discipline of engineering, you might still be working in the same field as someone that's from a different discipline. So kind of just one example. I saw that one question just popped up, but I don't see it in the chat. Perfect. So there's a direct message. So can I work in the cosmetic industry as a chemical engineer or lab work in general? How relevant is sustainability in chemical engineering careers, especially when the use of fossil fuels is still prevalent? So as I mentioned already, every single program at UBC will have a significant amount of sustainability in their engineering programs. Chemical engineering does work with things like fossil fuels, like you mentioned, but it's still looking at what are the most sustainable ways to do so. So obviously, like, to be ultimately the most sustainable, stop using those fossil fuels and everything like that. But until we're at a point where we can truly do so, there are sustainability issues to look at, especially in comparisons of if we do convert entirely to batteries. Sometimes the production of batteries and scaling up those systems so much is actually not as sustainable as using something that we already have in place. So sustainability looks at a lot of things, not just the environment, but a whole lot of different things. And so that's kind of one consideration, and that is something that chemical engineers definitely are part of. Chemical engineers, definitely you can do lab work as a research. So again, research is definitely an option for any engineering fields. And so that's one example of a career that you could do. And definitely cosmetic industry, if that's something you're interested in, you could look at chemical engineering. It might be, there's a few different options depending on what your interests are. Materials engineering is also one related to cosmetic industry as well. So there's a few different options within that depending on what your interests are specifically. And I saw another question about if chemical engineering also includes textile engineering. So again, similar, that it could be related to chemical engineering. It might also be related to materials engineering. So there are lots of different options within that. So the next one I want to talk about is civil engineering, and I realized that I made a mistake on this slide and I put in the wrong career titles. So these are accidentally the career titles from biomedical engineering. So my apologies for that. Some career titles for civil engineering would include things like structural engineers, things like civil engineering, again, is still very related to environmental engineering in a sense where you could be looking at city planning and all sorts of different things along those lines. So there are lots of options within civil engineering, and what civil engineers really do is that they shape the world. So they analyze, plan, design, construct, and maintain essentially the built environment around us. So the communities and infrastructure we rely on for safe, healthy, and sustainable living are what civil engineers work on. Those companies listed on this slide are correct, though. So those are a lot of the main civil engineering companies that that they'll work with for some of the top ones for our co-op program, essentially. And some of the sub-disciplines of civil engineering would include things like environmental, construction, geotechnical, hydrotechnical, materials, structural, transportation, and urban engineering. So those are all examples of things that civil engineers could work in. In addition to kind of some of the skills on the screen, a lot of civil engineers will also make use of computational tools and software, so things like MATLAB, Excel, VBA, Python, CAD software, all of those sorts of things as well, while also kind of maintaining those skills listed here. All right, so the next one is computer engineering. So whether we're looking at systems that control our phones, our cars, planes, robots, any automated device probably has a software or hardware engineer helping to create it. And so that's really the basis of computer engineering, where students in this program will learn to develop, design, and test software, computer networks, and protocols. Now, one of the main questions I get asked about computer engineering is what is the difference from computer science? And really the difference is how involved in software you are. So computer engineers are going to be looking at more of those large-scale systems, looking at more of the integration into hardware, and so all of those kind of bigger pieces and pulling those little pieces into the kind of bigger designs. Computer science tends to look more at the software side and looking at, smaller scale, so things like developing apps potentially, but not necessarily the integration of an app into an operating system, for example. And so that's kind of the main difference between the two. Since that is a question I get asked a lot. But you can see on here the skills that a computer engineer would do is really applying computer hardware architecture and software design principles to build embedded systems together. And that could be things like avionics systems, industrial robots, anti-lock brakes. So not just computers, but anything that we kind of use in the world that has some sort of computerized system would be what computer engineers can work on. Again, lots of different options for career titles. These are just a small sampling, as well as some of the main companies a lot of our computer engineering students work for. The next program is very related to that one and is in the same department. It is called Electrical Engineering. And so electrical engineers do very similar things, but will also make like essential medical equipment, design wireless communication networks. They might predict earthquakes. They might invent new ways to generate and conserve energy. I know one of our labs at UBC is working on some battery solutions for the future, essentially. And so one of those things that they are looking at is the possibility of, if you've seen a wireless charger for your phone, making wireless chargers for cars. And so can you have a wireless charger in your garage, for example, that you can drive on top of and it just automatically starts charging your car? So that's kind of one example of something that electrical engineers would do as far as research. For companies that our electrical engineering students go on to work for, things like Tesla, Intel, we have students that go to Microsoft as well. So electrical engineers are really looking at like electrical designs of various systems like communication, control, power distribution, lighting, and other systems, as well as using specialized software to perform various technical calculations. and also a lot of coding programs as well. The next program I'm going to talk about is engineering physics. So this one is a fairly unique program, and students really get a solid foundation in applied physics as well as a blend of electrical and mechanical engineering while gaining a lot of design experience. So engineering physics is a little bit different than some other programs because it does still have a lot of that really science basis to it, but it is also working with combining that to apply that knowledge to solve problems, which again is the basis of engineering in general. But engineering physics can look at all sorts of things. I've talked to students that work for or have done capstone projects with things like is Canada's particle accelerator on UBC's Vancouver campus. So there are a lot of different options that students can work in. And the next video I have is an example of a student named Yucheng, who is a graduate of engineering physics, and now she's actually doing research as a PhD student at UC Berkeley, working in robot learning. So you can learn a little bit more about kind of some of the current projects she's working on.
What are some of the projects you're currently involved in?
For me, my research interests really lie in trying to get robots to work in the real world. So for me, a dream would be coming home and then having a robot maybe in the kitchen be able to cook something for me. But that's really hard because everyone's home is different, and learning how to cook, I mean, it's already really difficult for a person, much less for a robot to learn how to do that on its own. For robots to really work in the real world, they have to be able to learn and adapt to different situations and different tasks that they have to do. And they also have to learn how to work with people and around people. And so some projects that I've worked on more on the human-robot interaction side deal more with having robots learn how to better help people or assist people, whether that's a physical robot in the real world or an assistive agent that you might have on your phone or something. And one of the projects specifically that I was working on most recently was dealing with how to have these agents learn help people by empowering them.
Yeah, so next question, what stood out to you?
All right, so that's again just one example. I know someone was asking about working in a lab and doing research, and so that's an example of she is currently working and doing research on robots and that human-robotic interaction. So the next one I've mentioned a little bit about already is environmental engineering, and so environmental engineers really study engineering problems from the perspective of maintaining and improving ecosystem health, addressing climate change, and improving biodiversity. Environmental engineers solve problems that the world faces related to waste treatment, reuse and recycling, as well as the mitigation of air and water pollution and remediation of contaminated sites. So those are some of the examples of different sorts of areas that environmental engineers will work on. And you can see that there is a lot of different options as far as their careers that they can have. And again, this is just a sampling of a list. For some of the skills that environmental engineers will really gain is really developing and implementing prevention and control technologies like air pollution control, soil remediation, and solid waste management. They'll conduct studies and technical analysis of field data to identify hazards and risks of engineering projects to the public and the environment. So again, that might be where they're working very closely with a civil engineer to understand how a new building or a new project is going to affect the surrounding environment, essentially. So there are, again, lots of different options. This is another field where these engineers will use modeling, computer modeling to analyze what those issues might look like and how we can kind of solve those issues as well. And the next program is Geological Engineering. So geological engineers study geotechnical engineering, geoenvironmental engineering, applied geophysics, and mineral and energy resources. So work can focus on feasibility studies for large energy and infrastructure projects, might focus on landslide hazard management strategies, potentially water resource engineering, site remediation technologies as well, and geotechnical design or other important focus areas. Yes, geomatics engineering is related to this. So some institutions will have specifically geomatics engineering. Geological engineering, you could still work as a geomatics engineer, so that is an option. Geological engineering is going to be a little bit of a broader field than something as specific as geomatics engineering, but it does kind of cover all of those sorts of areas. So I do have another video of a geological engineer who is going to share her experience. So Kate completed geological engineering, is now working for a company called Tech Resources, and that is the same company that she completed her co-op program with. So if you are working as co-op as part of your degree, then that also gives you a great experience to then go back and work for that company after you graduate. So she's currently working on a new project at a coal mining site, and so I'll let her share what that project looks like.
A bit about some of the projects you're currently working on. One of the projects that I'm sort of involved in right now is implementing a new initiative that they've been trying to start at the mine, where we're looking to recover thinner and thinner coal seams. And the really easy ones to recover are super thick, and it's really easy to justify cleaning them and recovering a lot of it with our equipment. But we're looking at trying to recover thinner and thinner seams, which is tough because a lot of the cleaning process and removing waste rock from either side of the seam is what becomes really challenging to get a good project and takes a lot of equipment hours, which can sometimes make it less economic and difficult to recover. But we're looking at doing the math on figuring out how much more we can justify recovery. Moving on,
So that's just a really quick video about one of the projects that she's currently working on. And just to give some background, coal seam is basically when you are getting coal out of the ground, it runs in a seam through the rock. And so if it's a very wide seam, it's easy to get that coal out. If it's very thin, then that's where she's mentioning that it's harder to get out. And so her job is actually to figure out how to do this and how to solve those problems. And so she's currently working at a coal site out in the Rockies in BC, so in the kind of Fernie area in BC. So that's, again, that's just one example, and not every area of geological engineering would focus on that, but that's one example of what she's working on currently. The next program is integrated engineering. I always get lots of questions about this. I personally think it's a very cool opportunity because integrated engineering kind of combines multiple engineering areas together. So it provides a real baseline in core engineering subjects like materials, solid or fluid mechanics, systems involving biological, chemical, and electromechanical components. And it really allows you to kind of combine two different types of engineering. Now, I purposely don't have any career titles listed here because you could go on to work as essentially either of the areas that you're studying. So the if you combine mechanical engineering and civil engineering, like the next example I'm going to show, you could work as either a civil engineer or as a mechanical engineer or as an integrated engineer. And so it's really, really broad. We have students that work for integrated engineering that go on to work for a lot of other companies, again, based on what two kind of areas they choose to highlight. One of the really unique things about integrated engineering is that it really, really focuses on entrepreneurship, and so students will gain an entrepreneurial attitude and resiliency to solve complex technical problems, as well as focuses on a lot of project management principles in a variety of settings. So the next example I have is the last video to share with you, although we still have a few more programs to chat about. But this is Sarah, who is currently working in Spain on the new FC Barcelona stadium. So she is helping to redesign that. So we're going to talk about, she's going to share about kind of the project she's working on. As I mentioned, she did a combination of mechanical and civil engineering and did a focus on sustainable building sciences.
to me. But I loved the project. I fell in love with it. It had all of the sustainable kind of aspects that I was looking for because it was the renovation of the existing building within a super dense urban area. It wasn't like a new rebuild like some of these huge like North American stadiums that are being built now. So fell in love with the project, and it was also an opportunity to move back to Spain. And I started, from the bottom, like doing what a first year engineer will end up doing. I worked with the engineering team on the project, so we're on the client side, reviewing drawings for the building, the mechanical systems, the electrical systems, working under the professional engineers that we have on the team. And it was great. I learned a lot, participated for the first time in, meetings with the engineers, meetings with the architects, and seeing what those kind of dialogues look like. And through those meetings, I kind of realized that maybe I wanted to move away from the technical details. I loved having that background and that knowledge, but where I really wanted to be was more in the decision-making side of things, which kind of pushed me away from being 100% technical engineer to more of a project manager position. We've done multiple projects now. We've done a mini stadium, which is a stadium for 6,000 people, which we, together with the architects and the contractors, have designed and constructed now. So I got to see that whole process from start to finish, from the drawings to the construction site, to the negotiation of the contract. So that was a great experience. Then I worked for a little bit as project manager, junior project manager of the arena project. And now I work as the assistant project manager for the stadium project. So the whole urbanization project is the stadium. It's the biggest stadium in Europe, 99,000 people. And that's what we're working on now. So my day-to-day now has nothing to do with what it was 5 years ago. So no more reviewing drawings, no more taking out the red marker and talking with the architects. Now it's much more, because also the project is in a different phase, but it's much more negotiating with the contractors, working internally with our corporate services, with legal department, with purchasing department, with compliance department, presenting to boards of directors, trying to get approval. This has kind of naturally migrated me into more of a business-oriented engineer. So if there are engineers out there that are more interested in this path, I find that the marriage between the business world and the engineering mindset works really, really well, and a lot of people seem to think so as well, because you already have that analytical kind of mindset, but you're just not working so much in the nitty-gritty details, and you're seeing how to apply things together and produce new opportunities, which is really exciting. So yeah, my day-to-day now changes a lot, but it's much more management oriented.
So as you can see from what Sarah had to say, that she, is constantly working in different teams, and I think that's true for all engineers, is that you are really always working on a team and solving those problems. And so she's been working for the same company for about 5 years now, so you can see how drastically over just 5 years her role has changed, and she is working to help, as she said, to redesign one of the largest stadium in Europe. So that's pretty exciting. So the next program I want to mention, we have just a few left, is manufacturing engineering. I don't have a list of places that these engineers are currently working because the manufacturing engineering program has just launched recently, and so we don't have all that data yet of where kind of the most common co-op opportunities are. But what I can tell you is that manufacturing engineers really focus on a range of major manufacturing processes and platforms. They look at production management, modern manufacturing practices, including newly emerging practices in digital modeling, virtual machining, additive manufacturing, and composites. So really manufacturing is looking at anything to make anything that is manufactured better or more sustainable, reducing waste in the manufacturing process. So if you look around you in whatever room you're sitting in right now, any room that you're in, there is probably so many manufactured items. And so all of those things get produced at a factory, whether it's your phone, whether it's your desk that you're sitting at, or whatever it is. There are so many things that are manufactured in the world, and this is a new program that really allows students to gain a lot of skills. And so you can see it's really a combination of a lot of material engineering and mechanical engineering as well. Materials engineering is really where more of that focus is on the material solution side. So looking at the materials, how does it all work together in using economical and sustainable material solutions, in analyzing the physical, chemical, and mechanical structure and properties of materials in relation to how it performs, using various techniques, creating systems and procedures to extract, synthesize and process raw materials into advanced composites and biomaterials, and conducting research studies on things like corrosion, failure analysis, operational testing, and quality assurance. So that is essentially materials engineering, is looking at, what are we actually using in the world around us. Mechanical engineering is one of our last programs. So mechanical engineering creates and improves physical systems. Mechanical engineers are really in high demand in all sorts of different industries. I think in several of the examples we've mentioned already that they might be working with mechanical engineers from some of those videos that we talked about. So mechanical engineers can work in industries like aircraft, energy development, biomedical, mechatronics, manufacturing industries, all sorts of different areas. A lot of what mechanical engineers will do is learn to prepare drawings, schematics, diagrams, plans, and schedules, from really conceptual design to an actual built prototype. They apply heat transfer, fluid dynamics, and combustion concepts to design water and air conditioning systems. They'll use things like sensors, electronics, and actuators to develop things like smart devices. So mechanical engineering is really looking at all of these different things related to any sort of mechanics, fluid dynamics, kinematics, and mechanical design. So lots of different options within that. You'll see some of the companies listed here are actually biomedical companies that you can work with because that is one of the options, but there's also other options and various different types of careers that you can take that are looking at a whole bunch of different fields entirely, while you're still, you and another mechanical engineer essentially could work in entirely different fields and still have the same degree. Now, the last program that I want to talk about is mining engineering. So mining engineers focus on finding ways to extract minerals or metals from the earth. Their expertise in mining, mineral processing, and mine waste management is highly sought after around the world, essentially wherever mines are located, which is going to be most places in the world. A lot of the skills that they will have is to design and develop underground and surface mines, so including ventilation, drainage, transportation systems, maintenance programs. There's a ton of AI going into mining right now as well, so machine learning and AI, if that's something you're interested in. Mining is a huge field for that right now. So there are lots of different kind of opportunities along those lines, but it will mostly focus around basically how do we get those materials out of the ground. And there was a mention about fossil fuels before, about how do we, we are trying to move away from that. But if you look at things like a battery, if we're using batteries, a lot of those minerals required as part of a battery, those minerals and metals, need to be mined. And so mining does do that in a sustainable way, as sustainable as possible, and looking to make that more sustainable. But those are lots of ways that that mining is required in many aspects of our lives, especially for battery production. So that is a lot of detail about all of the different programs that we offer. So no matter what field of engineering that you might be considering to pursue, engineers work to make our world better. So if you like working on a team, you love solving problems, you love improving our world by saving lives, by improving health, increasing sustainability, any of those things, and engineering might be a field that would be really great for you to consider in the future. So I know that was a big deep dive into all of the programs that we offer, but I hope that gave you a little bit of a sense of what some types of engineers do for work. Some of the resources that I use to put this together is that we have called What Can I Do with My Engineering Degree? So I'll put that into the chat. You can look up those details, so that will have even more options for different career titles. If you look at the national occupation codes as well that Work BC has, I cut down to what I thought were some of the most interesting job titles and kind of the easy ones to understand, but there are probably like 20 or 30 job titles potentially for each type of engineering that I kind of cut down and edited for this presentation. So you can definitely check out the Work BC page as well to explore different careers in engineering. And just before I wrap up and open up for any additional questions, those videos I featured are from our Behind the Career series. So if you want to see more about any of those videos that I showed or about any of the other engineering programs, we have videos for every single engineering program that we offer at the Vancouver campus. You can go to youtube.com/engineering stories to check out those videos for more detail about what recent grads in engineering are doing as part of their work and what their day-to-day life looks like, current projects they're working on, and all of those sorts of pieces. So that's a really great resource to utilize. That's it for all of the information I wanted to share with you. So thank you for sticking around. If you do have any other questions, please feel free to use the chat. You can also email me at any point in time. My email is erin.fair@ubc.ca. So please let me know if that is, please feel free to email me at any point in time over the next few years if you have any questions before applying. So I see some questions coming in. I'll stick around for a few more minutes to help answer those. I know that this was a huge information dump today, so hopefully that helped you kind of get a sense of some of the programs. But again, keep exploring. We have events coming up all the time for you to explore engineering in more detail. So I'm going to stop sharing my screen, but I will stick around to answer some questions. So one question came in. I heard from someone that there will be a mechatronics engineering option in the coming year. Is that true? And if so, do you know when it will be available? Yes. So mechanical engineering has a few options available. I'm just going to pull up the link so that you can see all of those options. So for mechanical engineering, you can there are options. So your second year in mechanical engineering will be what's called Mech 2. And then in your third year is when you can get a little bit more specialized. So there are options in biomedical, mechatronics, and thermal fluids. Or you can just stay in the general mechanical program as well. So that mechatronic program option already exists, but here is the link for you to check those out. Would engineering physics be considered as a major and a minor? So engineering physics is just a single program. So for engineering, we do have minors available that you can take. It is an option, and you would be adding it to your degree, and it will likely extend your degree by a little bit. So engineering is essentially like your major, but it's not the same as other programs where you would have a major and a minor. You can just have engineering as your degree, or you can add a minor in either commerce, entrepreneurship, arts, science, or honors math. So those are those options to add a minor, but engineering physics itself would be your discipline that you're in. You could add a minor to that if you're interested. So thank you everyone for joining today. If you have any other questions, I'll stick around for another minute or two, but please let me know if you have any other questions. Otherwise, thank you so much for joining and for spending part of your evening with me. I hope that you enjoyed getting to learn more in depth about all of the programs we offer and what careers could look like in some of those.